Let's do one more thing with our motor example. Let's make an airplane that has a bunch of motors in it. Okay, and we'll see where that goes. Okay, so what I've done is I've made a driver here, and if we were to make an airplane, airplanes end up having a what's called a tail number, which is the identifier for the airplane. Okay, and we'll just start out with that. So this is somebody manufacturing an airplane. Oops. Gotta say new airplane. Okay, so if that's how an airplane starts out, I'm going to go and create an airplane class. No main in it. And I know now that the constructor should say public airplane string, the tail number coming in. And I'm going to record that information someplace inside this class. So that means I need a private variable up top to record the tail number. Okay. A piece of internal information that an airplane might have is something like total flying hours, and so we'll set total flying hours to 0. We'll write a getter for it. Okay, so that sort of stuff should be a piece of cake to you by this time. Should be total flying hours. And now we need something to change flying hours. So the plane at some point is going to fly. So if we add more hours, then total flying hours just goes up. More hours. Okay, so nothing serious so far. Okay, well, let's go back to our driver. And when the plane is being built, somebody's got to make a motor. So the motor is going to have some sort of serial number associated with it, and it's going to have some maximum number of hours that can be run. And then the motor gets dumped into the plane. Okay. Now, conceivably speaking, more than one motor is going to be added. Airplanes would have 2 or 4. So let's just add another motor here. The other way that you can add a motor is to forget about the variable entirely and just say add motor, new motor, some motor with some number of hours. Okay, so in this case I made a variable that was going to remember the motor, but I really don't have to remember it. The plane is eventually going to remember that the motor is a component of the plane. So if you want, you can just stick the new right in there and just pass along the information about where the motor is directly to the airplane. Okay, Either way works. This way is probably more typical at this point. So we'll go into the airplane class and we'll add motor. What are you going to do with the motor? Possibly more than one of them. Airplanes got to remember them. So where do you want to put them? The list. Okay, so we'll make a list up top. So private list of only motors, all motors that the plane happens to have. And we need to initialize that variable. So we'll say all motors is a new array list that can only contain motors. And use the yellow bulb to get the correct import of the utilities and the correct import there for array list. And when you add a motor, all that you're going to do is dump it onto the list. Now we've saved it. Okay, so far so good. Let's talk about add flying hours. When you add flying hours, the total number of hours on the airplane goes up. What should happen with the motors? The hours of service for the motors should also go up every time the plane flies. So that's fairly typical of airplanes. Every single component gets hours recorded for it so that they can change them out whenever they've been around too long. That's also another really good check for Java classes. The rule is if the one variable at the top of the class changes, total flying hours, I wonder if there's any other things in the class that need to be updated in order to account for that. Okay, so if I'm going to make total flying hours increase, I need to make all of the motors increase. So how do we do that? Englishy statement would be to what's the important thing here? What are you trying to get at? The hours of service in all of the motors. So we're going to have to go grab each motor in turn. So we're going to go through all of the motors. Anytime you see go through all of them, that's some kind of loop. For each is the easiest kind of loop to write. So for motor, a motor in all motors, so that motor variable, a motor variable, is the thing that's changing. So we'll talk to whatever motor we've currently got and we'll add more hours to update all of the motors. Okay, so there's just another example of a for each for you. Okay, so now the tricky part. What's the driver upset about here? One too many brackets. There we go. So you can now add as many motors as you want, and you can do my plane dot add flying hours, 20 more hours, and that should add stuff to each one of the motors. So notice that it's also fairly typical in the things that we're building. This is sort of the construction phase of the thing, and then eventually we move along to actually using the thing in the driver to just try it out. Okay, so this is we do the plane will actually be in service and it would be flying and doing all sorts of things. Okay, At some point, suppose that I want to see all of the motors and how many hours are on them. Now the question becomes, how do I go and get that information off of the airplane? Because it's now, we've purposely buried that entire list of motors inside the airplane where it can't be seen on purpose, so that people have to ask us for them. So how can I retrieve the motors? There's at least 3 different ways to do it.
The motors or the hours?
I want the actual motors. I don't want the hours for them. It's really typical in Java that quite often when you go and get something, you don't just get a piece of the thing, you get the entire thing, because when you have the entire thing, you can ask it all sorts of questions rather than just being stuck with one piece of information. So somehow we need the ability to go back in the driver and retrieve all of the motors from the airplane. How would you do it if you were trying to retrieve just one motor at some point in this code without sending it out anywhere? Using what? A get. So all motors dot get whatever position, we would get something like motor number 0 or motor number 1 or motor number whatever the number happens to be. Okay, so there's your hint to say, well, okay, if that's what I would do inside to talk to this thing, all I'm really trying to do is retrieve that thing and send that value out. So what we'll do is we'll make a separate getter here. So the thing that comes out is a motor, and the thing that we're going to supply is its position on the list, and then we'll retrieve that motor and that now becomes the word position, and we'll send it back. Okay, so that would enable somebody in the driver to say my plane dot get motor number 0 and put it into a motor variable. Okay, so one of the things that's happening here is as soon as you bury that variable inside of a class and mark it as private, you're saying you're going to have to talk to me if you want to change it, and you're going to talk to me if you want to see anything about it. You're going to have to ask me for it, and I'm going to have to give it back to you. Okay, and so it's fairly typical that this thing just repeats what you would do internally. If you wanted to talk to the motor internally, you would do that. So if somebody wants to see it outside of this class, you have to send that motor back out for them to have a look at. Okay. Well, in the driver, we have a little problem here. Remember that the flying hours get incremented, and then this line of retrieving a motor happens weeks later in the program when somebody comes along and says, oh, maybe it's time to do service on this airplane. So they may have forgotten how many motors are on this airplane. Don't know why they would, but let's just suppose that they don't know. Is it 2 or 4? Don't know. So we got a problem here, because if you want to go through all of the motors of the plane by retrieving them 0, 1, 2, 3, 4 in a counted loop, how do you know how many there are? right? Let's just put this into a loop. Let's just call this don't know how many. We could go through and we could retrieve them if we wanted. Let's just put some big number in there and see what happens. So that becomes I. So we'll just retrieve all the motors and we'll print them out. Okay, run it. And there's some nasty error messages, and it says, oh, for some reason we printed out motor A, motor B, the first two motors, and when we went to get the number 2 position, all of a sudden there isn't a number 2 position in this thing, and so Java kills the program. And it killed it at that line when you tried to retrieve the number 2 guy. So what do we do to fix that? The 99 is the bad thing.
Yeah.
Who's holding on to the information about how many motors there are?
The list.
The list is, but we can't get to the list unless Airplane tells us. So Airplane now has to supply a getter that returns the number of motors that are on the plane, which is what? Who's keeping track of the motors? What variable? All motors. So all motors is the thing you want to talk to because it's got all of the motors stored in it, and then you can go down the list and there's size. Okay, so when somebody asks me, the airplane, how many motors you've got, I don't deal with it, but I know who can. Oh, the list is keeping track of how many there are, so I'll ask it. It says 2. I'll send the 2 back to whoever asked. Okay, this is also fairly typical Java and good programming style, is that you've got these classes that basically just act as a middle manager, right? Which is what Airplane is doing. It's just taking information and getting somebody else to deal with it, and then when somebody asks a question, it asks one of the subordinates, passes the information back to them, and doesn't really do much. Okay, welcome to middle management. Okay, so now that we've got those, in the driver, we can change that 99 to let's talk to the airplane and have it tell us how many motors are there, and then we can use that to go through all of the motors. Okay? And now the program doesn't die because it knows when to stop. Okay? So one of the ways that we can dig all of that information out is by using positional notation, and the rule for positional notation is that you've got to be able to ask 2 questions. You've got to, or got to be able to do 2 things. One is you've got to know when to stop, and the other thing is you've got to have the ability to say, get me the 0, 1, 2, 3, retrieve the numbered items. Okay. The only problem with that, and that's the traditional style, is that in order to go through all of the motors, we need to use a counted loop. And we know that counted loops are the ones that are the most error prone. What I'd actually like to do to go through all of the motors is say for motor, some motor in my entire plane, let's just print out some motor. Okay, so there's an alternative loop style, And this one we know is better because there's less work involved and it's not going to have very many errors in it. But we've got this issue here. And the issue is that it says, see that word iterate reappearing all over the place? Remember when we saw that yesterday? We said we needed, it was possible to get an iterator to run through a list of things. And so what it's basically saying is this code is going to translate into that iterator notation, that longer notation, but you don't have the thing in the plain class that gives me that ability to run through all of those things. Okay, and so that's why it won't do the for each. It doesn't think it has the tools to do it. So the issue is that this class is missing the ability to iterate through things. Who has an iterator? All Motors has that iterator thing, and the way you would use it is you would say all motors dot, and this is the silly one, dot iterator, which is really get me an iterator. And if you had one of those, you could run a for each or run an iterator method on the thing, right? That little iterator pattern. But in this case, we don't really care to use it ourselves. We're just trying to give it back to the main program so that they can use it to run through things. So if we made public iterator only for motors, iterator something that looked like that. Just let me get the bulb in here. This is saying we could ask the array list to give us an iterator. The thing that it would give us is one of those things, which is what a for each requires in order to work. And what we're going to do when somebody asks, or when somebody asks for it, is we're just going to get array list to give us one. And so this thing, I mean, you could call it get iterator, but I'm sticking with the pattern of calling it the same thing that array list does. So in the same way that we asked array list, said what's your size, and we passed it on, we're asking array list to give us an iterator, whatever that thing is, and sending it back out to the main program so that the main program can make use of it. Okay? No difference there, except the airplane driver still isn't happy. And this is one of these ones like with sorting. Remember, you had to say implements comparable to say that facility is available inside. This is another one of these ones in Java where you have to announce that that little thing is available for people to use. And the way that you do that is you go up to the top here and you say implements iterable for motor, which is basically what the error message says. And that's the announcement that says, basically translated, it's possible to use this thing inside a for each.
You say both when it's comparable and iterative?
Yeah, you can. Remember, implements, the question is, can you say both? Well, yes, you can, because it's just a standard, and so you can say, I do more than one standard thing. I speak French and Spanish.
What's the syntax of that?
Comma. Implements, comma, as many things as you want. I speak French, comma, English, comma, right? All of the standards. Okay? So, now that we've done that, if you go back, if we save this thing, all of a sudden notice that the for each will work. Okay? So this becomes the easier way of doing things. It's not unusual for somebody to provide both techniques inside one of these classes, because that gives people the ability to either go through all of them or selectively retrieve ones that they're interested in. Okay? But in general, you're either going to have positional notation to retrieve things, or you're going to have an iterator as a method for retrieving things. Those are largely the two ways of getting things out individually.
How that code that we just did there relates to my plane? Because I don't see anything here saying my plane.
The my plane is right there.
Yes.
So
But
remember,
how that relates to the what words make them.
well, remember this code, when the compiler sees it, it's going to translate into something. And the translation looks like this. Make me an iterator, and the other day we called it secretary, so I'll use the same word, even though that's sort of bad for airplane terminology. So there's a secretary, and we'll talk to all motors, and we'll specifically, or sorry, my plane. I'll ask for the iterator specifically. And there's the call to that method we just made. And make sure we do the import of the utilities one. And then it's this while loop while secretary has next. We'll use the same word here, some motor. Is talk to the iterator. Get the next one, and then print it out. Okay, so when you write this in Java, the compiler will translate it into the longer form, and notice that the longer form specifically talks to the plane and says, go get me one of those iterator beasties, which is actually coming from the array list and just transferred to us. Okay, so there's now 3 different ways that you could retrieve the same motors. Okay, is there another way to get out all of the motors? There's actually one more way. And I've seen people do this. There's this variable here, all motors, and all motors is just a list of motors. So why don't we return that variable? Sure, we can do that. Down here someplace. Public list of motors, get all motors. How about that? That would work, because I can go back to the driver and I can do the same thing. I can say, talk to my plane, get all motors, which is really a list of motors. And then I could just do a for each on that. Print out that way. and to the import statement for list, the utilities version. There we go. That still works. Any problem with that? What if I do this? What just happened? I removed motor number 0 from the list of motors. Airplanes still have the motor or not? Votes that airplane still has the motor? Votes that it doesn't? Well, let's find out. Let's just put a print statement in here. After removal, and we'll just run another for each. Let me just steal that code. Here's the for each that prints out all of the motors on the airplane. I'll use exactly the same code we used before. Are we going to see both A and B, or just B? Run it. Just B. Why is it just B? Notice what we sent out of the airplane. We sent out our variable, which is the array, and so we're now sharing the same array. We basically gave permission to go and use things from that array, and so somebody in the main said, oh, I can just delete motors from the airplane. Is that a good thing or a bad thing? It's probably a bad thing if the name of the game is to try to get the motor to, or the airplane to maintain control of all this stuff. All of a sudden you're turning around and saying, here, go ahead, play with the motors, I don't care, do whatever you want with them. Okay? Actually play with my list of motors, right? And so they can say, oh, I think you've got one less motor than you had. Well, hold it here. You should ask permission if you want to remove one of my motors. Okay? So you have to be careful about that sort of thing in the airplane class, because yes, it was private up here, and it's true that you can't get at those variables because you always send out a copy of those small variables. But things like lists that contain a bunch of things, if you ever send out that variable, then all of a sudden you're giving people access to that entire list to do whatever they want with it, which is generally going to be a bad thing because you lose control over the ability to maintain your own list.
So when we return a variable, it creates a copy of the variable.
These guys will be copies. So total flying hours, if you return total flying hours, that's a different number.
Right. And when we
But
send a list, it shares the same address or whatever.
you get the list. You're talking to that thing which has a bunch of sub things, and so you can now ask that list to do whatever you want.
There is
Okay.
a restriction that you can put?
Can't put a restriction on it in Java. There's no easy way to do it. So what should we do here instead of returning the actual thing? Put it in a different list, right? So you can copy your address book and give people a different address book, but you don't want them to have access to all of your address book directly. So we need to make a copy. So let's do that the long way first. What we need to do is we need to make a list of motors that's a copy of all motors. And so what we'll do is we'll make a brand new empty list that can only hold motors. And then we'll go grab each of the motors in turn. Can't see the end of my line anymore. There it is. We'll go grab each of the motors in turn, so that's a for each. And every motor that we get, what do you want to do with it? Copy it to the other one, so that's copy of all motors dot add whatever motor came off the first list. And then what we'll send back is the copy of all motors. Okay, so that's go through the original list, take every single motor, add it onto the new list, and then send back that list that you just made as the copy. Now what's it going to print? Haven't changed the main program. I removed the 0, 1. Run it again. And it's still there because I deleted the thing from my copy, and it doesn't affect the ones that are on the original airplane.
If you were to just say that empty list is equal to all motors, wouldn't that be the same thing? Or would that just give you permission?
That would still give you permission because it's still the same thing. His question was, why don't I just do this? Copy of all motors equals all motors. That's still the same variable. You haven't changed it. It's still the same list. Okay, so that won't work.
And what if we want to actually remove one from the copy on the driver?
The driver has removed one from the copy. That's what that thing did, and it didn't affect the original.
And if I want to print that copy instead of the...
You can print out, you would just change this thing to be plane motors instead of my plane. To print out all of the motors on your list. Okay, so it's really typical if you're trying to maintain control over things like this that you don't send out that list of things. You send out a copy of it so that people can do what they want with their copy and you get the original. What if you wanted somebody to delete a motor from this plane? For whatever reason, the maintenance guy wanted to actually remove one. We can write another public void remove motor, and we can say remove by position is fine, and this would be all motors dot remove whatever the thing is. Now you're saying, well, I could have done the same thing from the outside if you would have given me the list. The difference is that right in here is your opportunity to exercise control and put in some if statements to go do or I don't want you to do that. You're having people ask you. You can give them blanket permission if you want, or you can put your checks in there to make sure that you do the right thing. Okay? So that's the control, because that's the only way that they can get at those motors is through that method now to do the removal. Okay? Well, it turns out that this idea of copying a list happens so much that there's a shortcut for it. Because this is just make a new empty one and then copy everything into it. The shortcut is to not write the loop at all, and there's another constructor for array list that says make a copy. And it does exactly what we just wrote. All the constructor does is it makes a new fresh one, copies all of the things and into the list that it's got. Okay? So you'll often see there's the shortcut. You could shorten this to return new array list of the motors, but the fact that there's a new there says that you're getting a copy of the thing and not the original anymore. Okay? So more and more, what we're going to start to do is we're going to manipulate lists by sending whole lists back and forth and copying them and doing different things with them. Because this is fairly usual. Give me a copy of the list so that I can do something with it. I want a copy of all of the students that you think are in Comp132 so that I can delete a bunch of them or alphabetize them or do whatever I feel like doing without disturbing your original list. Okay, and let me just double check and make sure I've gone through, yeah, pretty much all that stuff. Okay, let's do some setup for some stuff we're going to do tomorrow. Last question. Is that all okay? See where that all's gone? Okay. Let's do a new topic. What we're going to do is we're going to sort of repeat this whole process on a different example, right? Same thing all over again. So let's pose a different problem here. Anybody here from Soup? Good, then I can make fun of them. Okay. So for those of you who aren't local, Soup is sort of a great distance away, and it's renowned for having people that are even dumber than people from Langford. Anybody else? Oh, okay, so yeah. And so basically people in Soup don't have much to do since it's so far from town other than go fishing. And once a year they have their annual fishing derby. And I'm going to go through and describe to you the way a fishing derby works, because what we're going to do is we're going to write a program that's in charge of managing all of the stuff for the fishing derby. Okay? So here's the way the fishing derby works. First thing in the morning, 5 o'clock before the sun comes up, somebody comes out who's going to manage the derby, and they put up a big sign that says Soup Fishing Derby 2014. Okay? And then they stand on the beach, they set up a nice table, and they wait for people to come and register and pay their fees and be part of the derby. Okay? So 15 minutes later, people start pulling up, getting their boats all ready to go in the water, and they walk up to the registration desk to register for the derby. Okay? So they're going to tell them, I'm Fred Flintstone, I want to register to be part of this derby. Okay? And at some point after everybody's gotten registered, say 6 o'clock in the morning, the starter sounds a horn, and everybody hops into their boats and they go up fishing. And the rule is that you can come into shore anytime you want, and you can present a fish to the guy, or you can wait until, just before the thing ends, and you can dump all your fish at once, one at a time. But one way or another, people are sort of constantly coming in and out and running up to the registration table. Okay? When they run up to the registration table, Fred Flintstone comes running from his boat with this fish in hand, and he walks up to the registration table and he says, hey, I'm Fred Flintstone and I just caught this big fish, and I think it's the biggest one, right? Do something with this fish. And the registration people are in charge of somehow tagging the fish as Fred Flintstone's, putting it behind the counter someplace so that they've got all of the fish lined up for all of the individuals, all set to go for when the derby ends. Okay. At 3 o'clock in the afternoon, big horn sounds, that's the end of the derby. Okay? And now you've got all of these fish sitting behind the counter, and one of them is the winner, and it's tagged with somebody's name. Okay? As soon as the derby ends, the fishermen rush the registration desk all at once, and what's their question? Who won? Who's got the biggest fish? So I want to know two things. I want to know who won, the person, and I want to actually see the biggest fish so that I can see whether or not it's bigger than the ones I caught. Okay? What's the second piece of information that the fishermen want to know after they know that they weren't the winner? Remember, the fish have all been stored away behind the counter. So
What's the difference?
they want to see how they placed in the Derby, right? They want to see how they compared to the biggest fish that was caught. So they're expecting that someplace there's going to be a list of all of the fisher people posted, so that with the biggest fish listed for each fisherman, probably in alphabetical order, so you can come out and find your name. Oh, there's Fred Flintstone. Oh, there's my biggest fish, and I can compare that to the one that won and see how badly or how well I did. Okay. Well, they want that list actually in two formats. They want it in alphabetical order so that they can find their name. But we also want a separate list that shows biggest fish, next biggest fish, next biggest fish, so that people can come and see whether they placed first, second, third, fourth in the Derby, because we'll hand out some money based on the first three placements or something. Okay? So they want two different forms of the list when the thing is done.
Can you use the same list to do that and just sort it?
Well, it's going to be sorted too. It's going to be just presented two different ways. It's the same information, but it has to be presented two different ways. Okay? So, let's go back to, just for a second, to this business of how do we store the fish? Because this is where the trickiness of the game comes in. Okay? So, we need a way behind the counter of organizing all of the fish for all of the fishermen that are going to come in. We don't just want to throw them willy-nilly everywhere and have to dig through piles of fish. Okay? So let's talk about organizing this setup. Okay? One way to organize it would be to get big green garbage bins and set them up behind the counter. Okay? And so if we're expecting 20 fisher people, we'll have 20 different big green bins. Okay? So somebody comes up and registers, and they put their name on the registration form, Fred Flintstone, and their phone number and all that good stuff, and they paid their fees. Okay? I've got this paper form. What should I do with this, with Fred's paper form? Go to one of the bins, the first bin, and tape it onto the front of the bin, and this is now Fred Flintstone's bin for all of his fish, right? So every time I get a registration form, I take it and I put it on the front of the big green garbage pail so that I have them all nicely there so I can plop a bunch of fish in for Fred, for however many he has. Okay? That's going to cost me a lot if I provide the bins. Can I do it in a cheaper way instead of me paying for bins? Have the people bring their own bins. Okay? So the question of who makes a new bin is important here. Does Fred bring the bin, or do I go out and buy the bin, is an important question. Okay? So we're saying Fred is going to make a new bin, and when he comes, he's going to supply the bin and his form, and we'll put the bin and the form together. Okay? And that's Fred's bin. He actually bought it. Okay? So that's where the new is coming. Okay? We had a choice there. Doesn't really matter which, but we chose to push the work to Fred. Okay? Let him cover the expense. Okay, good. So we've got all the bins set up. So now let's go back to Fred comes up and he runs up to the registration desk partway through the Derby, and he's got his fish in hand. How do we get the fish into the bin? How's, like, Fred can't see the bins, right? We're hiding them in a covered tent someplace on purpose. So that
Registration.
he walks up to the registration. What does he do? He's holding on to the fish.
It's them to record it.
Well, see, this is physically the important detail, because our Java program is going to look exactly like this. What did we do for registration forms when I used the registration form analogy? You register once, you've got your registration form someplace. What do you do if you want to go talk to the registration department again? Make another form, right? And so what Fred is going to do is he's going to take one of the unused blank forms, right, that were left over from the registration process, and he's just going to write his first name and last name on it. So now he's Fred Flintstone, he's got this piece of paper, he's holding the fish in hand. He walks up to the registration desk and says, oh, here's a form, sort of looks like the other one, there's my fish. What do you do if you're the registration person? Take these two things, go to the bins,
Matches the one, or the form.
take the registration form that Fred provided, the fake one, and you run that registration form all the way down through the line of all of the bins you've got until you find a form that matches the one that's on the front of the bin that's already there. Crumple up the piece of paper that had that extra information that Fred supplied, dump the fish into Fred's bin. Okay? So there's that idea that they're making a fake registration form that looks like the one that I'm trying to find, because then I just have to do the matching. Okay? Find the matching bin, dump the fish in, my job is done. Okay? One last problem. How do we find the winner? This is the fun part. What I've got is I've got 20 bins, 20 or 30 bins. Each one has probably multiple fishes in it. Each of the bins is marked with a person's name. How am I going to sort through all the fish and find the biggest one?
Go through each bin, find the biggest fish in each bin.
Oh, I'm lazy.
Let the fishes
You're going to make me do all the work?
You're gonna make
Let the
somebody else do
fishes.
it.
With the fishing in the
Let
hook.
the-
Who'd be the perfect people to do the work? The fisher people, right? So what we'll do is we'll get each fisher person, I'm being politically correct here, to stand in front of their bin, okay? And if I'm the organizer of the thing, what do I do when I encounter the first bin at the end of the derby? Fred's there. What do I say to Fred?
That's the biggest fish.
Hey, Fred, what's your biggest fish? Let Fred do the work, right? Okay. And then eventually, I'm going to go to Sam next door and I'm going to say, hey, Sam, give me your biggest fish. Okay? But for now, I've asked Fred, what's your biggest fish? Okay? How does Fred find his biggest fish? This is the fun part.
Here's one.
Fred's lazy. He doesn't want to do the work.
Ask the fishes.
Good answer. You ask the fishes. Fred pulls one fish out of the bin. He pulls the other fish out of the bin. He gets, I think this is the current biggest fish. He introduces the two fish to each other, and he says, hey, which one of you two is bigger? And this fish says, I'm the biggest fish. And Fred says, thank you very much. He throws that one away, grabs another fish out of the bin, introduces that fish to the one who's the biggest fish, says, hey, biggest fish, what's going on here? Oh, that guy's bigger. Okay, fine. That guy. So the trick here is to let the two fishies talk to each other, and eventually Fred just makes the introductions and he ends up holding his biggest fish. Organizer, I go to Sam. Sam does the same thing. He makes all of the fish introductions. Eventually, Sam's holding his biggest fish. Now I've got Fred and Sam, and I say, hey, Fred, Sam, which of you two is bigger? What do they do?
Their two fish talk.
They get their two fishes to talk to each other, and the two fishes make a decision as to who's bigger. One of them reports to Fred or Sam, and that guy says, oh, okay, I've got the biggest fish. And then we just go down the line. Okay? So there's the trick to the game. We're just pushing the work down a level. We're going to animate the thing, let everybody do their own level of work, and that's what we're going to write in Java starting tomorrow.
Hey, it's our time today. We could demo about 30.
Yeah, I'm there 4 hours this afternoon from 1:30 to 5:30.
1:30 to 5:30? Okay. Will you be in the office or like a lab?
In the lab, 150.
Gotcha,
Yeah.
thanks.
Common use is just like flat out static.
The whole point of the club is to be engaged in something. Oh, really? Yeah.